So good evening everyone. So today we are going to solve the week 7 assignment of AI constraint satisfaction problem. Okay, so the first answer, modern cars have up to 90 control units. What is the control unit? First you should know what is a control unit. 90 control units. Control units means brain of the brain. It is the brain. It is known as the brain. Okay, these control units. What does these control units do? These control units has software that relates signals to its faults, for a positive faults. Because the brain, suppose you have a pain, the brain, your brain signals that where the pain is coming from. Is the same thing over here. Have software that relates signals to possible faults. The diagnostic software in traditional control systems in cars. Okay, is a software that is custom implemented manually for each car, because diagnostic software, these are different for different cars. For each car doesn't mean that suppose Maruti Swift is there, so for one Swift there is some other some other software. For other Swifts some other software. Is not like that. For each model you can say, for each model of the car. For which the cost increases. Understood? तो diagnostic software क्या करते हैं? Is a software that is custom implemented manually for each car, or you can say for each model of the car. Model based diagnosis is based on a model of the device that predicts its behavior. It predicts the behavior. Okay, a terminal of a component is a model. Is the mechanism by which the component sends a signal out. Is the mechanism by which the component receives a signal from outside. Terminal means in and out. Okay, yeah, it can signal can come in, signal can go out, is the same thing. For diagnosing a device that has never seen before, okay, one can use the consistency based diagnosis approach. This can be used. And over here, let there be resistor of 3 ohms and voltage drop equal to current into resistance. Then what would be the options? 12, 4, 12, 4, 3. Now 4 into 3 is how much? 12. So this is the option. Okay, 15. It's not detailed. I'm not going into the physics of it. 15, 5, 3. So 5 into 3 is how much? 15. So this is also the option. Hope it's clear. Now for the purpose of diagnosis of a device containing a resistor which could be broken. Okay, it can only suffice if one knows quality that the observed current is 0 or non-zero. Current 0 या non-zero में क्या होगा? The resistor seems to be broken. Current can be 0, current can be non-zero. Now this one, a qualitative model results in working with a finite domain set of constraints. In a qualitative model of a resistor, what is the domain of values that current can take? Current क्या क्या values ले सकता है? एक पॉजिटिव ले सकते हैं, एक नेगेटिव ले सकते हैं और एक जीरो करंट ले सकते हैं. ओके, जीरो इज ऑल्सो करंट. एक पॉजिटिव करंट ले सकते हैं, एक नेगेटिव करंट, एंड वन इज जीरो करंट. तो दैट्स व्हाई दिस ऑप्शन इज द करेक्ट. नाउ लेट देयर बी 3 ohm. 3 ohm. ओके, देन द ओम्स लॉ इज यहाँ पे. कैन यू सी ओवर हियर प्रीवियस क्वेश्चन? -3 + 3, ये सारे वैल्यूज फॉल्स है. वी आर नॉट गोइंग टू टेक दिस वैल्यूज, कीप इन माइंड. ओके, नाउ लेट देयर बी 3 ohm. 3 ohm है. Then by Ohm's law, voltage drop equal resistance into current. ठीक है, तो which indicate the resistor is broken. Resistor is broken indicates क्या? Resistor is broken means current is not flowing. Current is not flowing. Current is not flowing means the value of current is 0. यहाँ पे 0 किस पे? इस पे 0 है, इस पे 0 है. That's why I've taken this. Okay, because 0 value is there. That's why I've taken this. Hope इतना clear हो गया. Simplest way में I'm explaining the things. Now given a set of observations from a device, that the first task of the model based diagnosis, ठीक है, तो is to determine whether the device has a fault. ठीक है, diagnosis किसकी होते हैं? Fault की होते हैं. Is to determine whether the device is working as designed, as predicted. In simplest models of diagnosis, ये बाकी सारे you have to just go through it. Okay, in the simplest models of diagnosis, each component has just 2 models, okay and not okay. That's all. Diagnosis में क्या होता है? The model is okay or the model is not working properly, not okay. A model of a device for model-based diagnosis constitutes of mathematical models of components, structure description describing connectivity of components. Now this one, this is very important. This is very important from the examination point of view. The Occam's razor refers to the heuristic that the simplest explanations are often the best. This is very important. The simplest explanations are often the best. A diagnosis in which the minimal number of components are faulty is preferred. A diagnosis in which the minimal number of components are faulty is preferred. This is known as Occam's razor. In consistency based diagnosis, a conflict set is a set of components at least one of which is broken. Consistency based diagnosis, a conflict set, कोई भी एक broken होंगे, at least one of which is broken, at most नहीं, at least. अब यहाँ पे एक दिया हुआ है, कंसिडर द ये फॉल्ट है यहाँ पे क्या, बल्ब वन और बल्ब टू इज नॉट ग्लोइंग. ओके, बल्ब वन एंड बल्ब टू इज नॉट ग्लोइंग, बल्ब टू इज ग्लोइंग. तो व्हाट आई डिड, यहाँ पे मैंने क्या किया, वाइट 6 में एक फॉल्ट हो सकते हैं आई टोल्ड, एंड एक बल्ब वॉल में फॉल्ट हो सकते हैं. बल्ब वॉल क्या होता है, बल्ब वॉल कैन बी फ्यूज हो सकते हैं, बट दे हैव गिवन नन ऑफ द अबव, तो लीव इट. लेकिन फॉर द सेम प्रॉब्लम व्हिच ऑफ द फॉलोइंग कैन हैव डबल फॉल्ट्स. डबल फॉल्ट में क्या हो सकता है, बल्ब वन एंड बल्ब थ्री आर नॉट ग्लोइंग. वाई दे आर नॉट ग्लोइंग, the option is also correct. Bulb 1, bulb 3 I have given. Bulb 1 and bulb 3. Why the option is correct? Because it may be that the filament is broken. That's why bulb 1 and bulb 3 is not glowing. Okay, battery is not working and battery and bulb 1. It's given na, over here. Battery and bulb 1. How the battery and bulb 1? I do not know. Because if the battery is faulty, the bulb 2 will also not glow. Seriously. That's why it's better that whatever you know, you just click it. Bulb 1 and bulb 3. This is the only option I prefer. So thank you. All the best for your examination. Bye and take care.